Welcome to The Explainer. Today, we are tackling a GMAT topic that seriously trips people up, time and work problems. You know the ones. If you've ever stared at one of those questions and just felt your brain freeze, well, you are definitely in the right place. It's such a common feeling, right? You read the problem, you see all these moving parts, people working, machines running, different hours, and your first thought is, okay, how in the world do I turn this story into an actual equation? That is the exact hurdle we're about to jump over.
So, here's the game plan. We're going to break it all down. First, we'll get into why these problems feel so tough. Then I'm going to give you a super simple two-type framework. We'll walk through the method for each one, and we'll wrap up with a clear, strategic takeaway you can use the second you see one of these on your test.
Okay, first things first. Let's just acknowledge the beast. Time and work problems feel so dense because they're not really about just one thing. They're this mashup of percentages, ratios, and, maybe most importantly, your ability to just keep information straight. They're literally designed to test a bunch of skills at once.
But here's the secret. This is the one thing that just unlocks this whole topic. It all starts by asking yourself one single clarifying question. When you do that, you stop feeling overwhelmed and you immediately start classifying the problem, and that tells you exactly which tool you need to grab.
And this is that framework. I'm telling you, every single time and work question you'll ever see on the GMAT falls into one of just two buckets. That's it. Once you can spot the difference, you're not solving a random, confusing puzzle anymore. You're just following a clear, step-by-step process.
And this right here, this distinction is everything. On one side, you've got independent work. This is where people or machines have their own unique speeds. You know, think of a senior programmer versus a junior programmer. They work at different rates. On the other side, you've got group work. This is where you have a bunch of interchangeable workers, like, say, 10 bricklayers, and we just assume they all work at the exact same constant rate. That is the whole decision you have to make right at the start.
So, let's take into that first type, group work. The beauty here is that when everyone works at the same speed, you don't need some crazy complicated formula. The best tool you can use is something you already get, simple, common-sense proportions. Now, proportions basically come in two flavors. First up, we have direct proportion. This is just when two things move together. If one number goes up, the other number goes up too. And the math couldn't be easier. You just cross-multiply.
Check out this monkey and banana example. If 20 monkeys need 40 bananas, and you suddenly have 25 monkeys, well, it's just common sense you're going to need more bananas, right? The two quantities move together. You cross-multiply, and boom, you get the answer. 50 bananas. See? Simple.
The second flavor is inverse proportion. And you guessed it, this is when things move in opposite directions. As one number goes up, the other one goes down. Now for this, the rule changes a little bit. You just multiply straight across.
Let's see how that works. Say 20 men take 40 days to finish a job. What happens if you add more guys? Well, the job should get done faster. More men means fewer days. That's a classic inverse relationship. So you multiply straight across, 20 times 40, and then divide by 25, and you'll find out it's going to take 32 days.
Okay, let's switch gears to our second category, independent work. Now, when you're dealing with different work rates, the key isn't proportions. It's all about organization. And the absolute best way to stay organized is with a nice, simple table.
Say hello to your new best friend for these kinds of problems, the rate, time, work table. It's just a simple grid to neatly file away every piece of information. Who's doing the work, what their individual rate is, how long they work for, and how much work they get done.
But why even bother with a table? It all comes down to one fundamental, super important rule. You can't just add up the time it takes two different people to do a job. It just doesn't work that way. But what you can do is add their work rates together. So the entire point of this table is to turn everything into rates because rates are super easy to work with. All right, now for a pro-level trick that will make these problems so much easier. A lot of the time, the question won't tell you the total amount of work. Now, you could assume the work is 1, but then you're stuck with a bunch of messy fractions. Instead, you're going to pick a smart number. And the best number to pick is the least common multiple, or LCM, of the times they give you in the problem.
Look at how clean this makes the math. Let's say A takes 3 days and B takes 6 days. The LCM of 3 and 6 is 6. So we'll just assume the job is to build 6 little units. That means A's rate is 2 units per day, and B's is 1 unit per day. Together, their combined rate is 3 units per day. So to finish the 6-unit job, it will take them exactly 2 days. No fractions anywhere. Just simple, clean arithmetic.
Okay, so let's tie this all together into a bulletproof strategy for test day. You can forget all the confusion. From now on, this is your decision tree for any time and work problem that comes your way.
Here it is, your playbook. It's a really simple process. Step 1, you ask the big question. Are the work rates the same or are they different? If they're the same, you know it's a group work problem, so you use proportions. If they're different, it's independent work, and you use that RTW table. And of course, always remember that pro tip, use the LCM for the work number to dodge fractions and just make your life way, way easier.
And there you have it. What used to be this big, intimidating topic is now just a structured, solvable system. You've got the framework, you've got the right tools for the job. And this was never about memorizing a bunch of formulas. It's about understanding the logic and just applying a process. So the only question left is, which problem are you going to go conquer first?